All right, so in this next problem we have a block that is on a horizontal frictionless surface, and it's got a 100 Newton force that's acting on the block at an angle of 30 degrees. So what is the magnitude of the force if it establishes equilibrium? So we have a force F back this way, so what we really need to do is find out what is the force that's actually pulling it forward, because if it's at equilibrium, what this means, right, is balanced forces. So the force in the forward direction balances out the force in the backward direction. It is not 100 because there's a part of that 100 that's lifting the force up, lifting the block up. Kind of think of it as relieving some of the normal force, but that's for another question. So we want to find that x component. So the x component is equal to the force F times cosine of the angle between them, because this is the adjacent side. So that is 100 newtons times cosine of 30 degrees. And if you plug that into your calculator, you get 87 newtons. The next one, very similar question. We have but in this case we want the vertical component of the 300 Newton force. So we want this guy. So that is the opposite and hypotenuse, and we have a 40-degree angle. So that force in the y direction is equal to F times sine of the angle, and so that is 300 newtons times sine of 40 degrees. Plug that into your calculator. I actually didn't calculate that. And to 2 sig figs, I got 190. All right, the next one, 64. We have a hand of a lawn roller is held at 45 degrees from the horizontal, so there's the 45. Force F of 28 is applied to the handle as the roller is pushed across a level lawn, as shown in the diagram below. What is the magnitude of the force moving the roller forward? Okay, so that is this one right here. So this is the x component of the force. This part is pushing it down. This part is pushing it forward. So once again, this is equal to F times cosine of the angle. Okay, it's the adjacent side of the 45 degrees. So this is 28 newtons times cosine of 45 degrees. Throw that in, and I got a value of 19.8 newtons. Next one, 65. It says, neglecting air friction, compare the amount of time A takes to strike the plane to the amount of time B takes to strike the plane. Okay, so this is an idea of projectile motion. In the vertical, okay, this is important about, in the y direction, both start with an initial velocity of 0. Both are falling the height of the arrow, so the distance is the height. They're both accelerating at g. And so therefore the time, since all three of these pieces are the same for the arrow that's dropped and the arrow that's fired, the time is going to be the same. 66. A book is pushed with initial horizontal velocity of 5 meters per second off the top of the desk. What is the initial vertical velocity? Okay. So if I push something off the desk, the instant it leaves the desk, this is kind of like a cannon being shot from the edge of a cliff. The instant it leaves, it has no initial vertical velocity. And that's more, one way to think about this is that if I throw something in the forward direction, that also means that I'm not throwing it in the vertical direction. Might be an easy way to think about it. All right, 67. It says a golf ball is propelled with an initial velocity of 60 meters per second at 37 degrees above the horizontal. The horizontal component of the golf ball's initial velocity. So I have a picture that looks like this. I got my 60 meters per second. I have my 37 degrees above the horizontal. And I'm asked to find that x component. Okay, so this is adjacent side, so this is v cosine theta. So I have 60 times cosine 37. Throw that in, and I got 48 meters per second. Next one. This is a projectile motion one. This is actually a little bit complicated of a problem. So if I set up what I know in the horizontal and vertical, okay, in the horizontal, my initial velocity is, do I know? No, I don't know. I know the acceleration in the horizontal is 0, and the vertical, the acceleration is negative 9.81 meters per second squared. I know that it hits the smokestack 0.65 seconds later, so that's how long it's falling for. And I know that the initial velocity is 0. Now I know it's fired from 4.5 meters. Okay, so we know that it's going to take a parabolic path down to the ground, something like that. And so what we don't know is how far it falls. So I don't want to put the 4.5 in for my vertical distance, just because odds are, based on the question, that it's going to fall some distance below but still be off the ground here. There's going to still be some distance, okay? This is what we're after, is to find that vertical distance. So basically what I'm going to do is I'm going to find how far it could fall vertically in the 0.65 seconds and then subtract that from 4.5. Okay? So since d equals VIT plus 1/2 AT squared, the initial velocity in the vertical is 0. I take my 1/2 times 9.81 times 0.65 squared. And when I plug that in, I get a value of 2.1 meters. Okay, and once again, this is not how far it is above the ground. This is how far it falls. So if I take that away from 4.5, I get 2.4 meters. At the instant the snowball is released, the horizontal component of the velocity is approximately. Okay, so now this is what I want to find. I know the distance is 15 meters, and I know that it takes 0.65 seconds to get there. So with these three pieces of information, use the same equation, d equals VIT plus 1/2 AT squared. Now this is in the horizontal. The acceleration 0, okay, and so my initial velocity is the distance divided by the time, and that is 15 meters divided by 0.65 seconds, and I got 23 meters per second. So this is 23 meters per second. Alright, so we have a machine launches a tennis ball at an angle of 45 degrees as shown. The ball has an initial vertical velocity of 9 meters per second. Okay, so let me set this up. Whoa. So in the horizontal and in the vertical, so my initial velocity here is 9 meters per second. The initial velocity here is 9 meters per second. And we also know the acceleration in the horizontal is 0. The acceleration in the vertical is negative 9.81 meters per second squared. What else do I know? I know the elapsed time. It reaches its maximum height at 0.92 seconds after it's launched. Okay. The speed of the tennis ball as it leaves the launcher is approximately... Okay, so for this one at least, this is a vector problem. So if I have 9 and 9 and I want to find basically the hypotenuse, right? So that's what I'm after. So this is a squared plus b squared equals c squared. We have 9 squared plus 9 squared equals c squared. C is equal to 12.7. So this is 12.7 meters per second. Okay. The total horizontal distance traveled by the tennis ball during the time of flight in the air is approximately... So, okay, so this is, we're looking for horizontal distance. Okay. So what I know is I'm looking for distance. Okay, that's my unknown. I also know how long it spends in the air. So if it takes 0.92 seconds to get to the highest point, then it's going to take another 0.92 seconds to get to the ground. Okay, and so that total time is 0.92 plus 0.92, or 1.84 seconds. So notice I have a D, a VI, an A, and a T, and that's going to be my fourth kinematic equation on your reference tables. And then the acceleration in the horizontal, since we're looking for a horizontal distance. So this is 9 meters per second times the 1.84 seconds to get a total of 16.6 meters. All right, so last page here. So we're looking at a cannon is elevated at an angle of 35 to the horizontal, fires a cannonball which travels the path shown in the diagram below. Okay, the ball lands 7 times 10 to the second meters from the cannon, 10 seconds after it fires. All right, it says what is Vx? Okay, this should say what is Vx, and then also consequently what is Vi. Alright, so in order to find Vx, I'm going to set up what I know. Okay, we're going to focus mostly on the horizontal. So I know the acceleration 0. I know the acceleration here is negative 9.81. I know the theta is 35 degrees. I'm not going to put that in either column. And then I know that it lands this far away. Okay, so that's a horizontal distance. So that's 700. And then it takes a time of 10 seconds to get there. And I'm looking for VI in the x direction. Okay, so that's my first thing. So notice that I have the same 3 variables, okay, as just a second ago. And so the acceleration in the horizontal 0. So my initial velocity, now this is the x initial velocity, okay, so this is the horizontal distance, this is the horizontal initial velocity, so that is what I'm solving for. And the reason I know that is that this is a horizontal distance. So my vectors, displacement and velocity, have to match up. So then I get 700 divided by 10, and so I get VI equal to 70 meters per second. Okay. So now what I have, now we have to think trig. I have 70 as my hypotenuse. Oh, I'm sorry. This is the Vx. That's what I just told you. I have this as 70 meters per second, and I'm asking to find the initial velocity, the hypotenuse of it, and I know that it's 35 degrees. So this is going to be a cosine. So we have cosine of theta equals adjacent over hypotenuse. And if I plug in cosine 35 degrees equals the adjacent side, 70 over the hypotenuse. Do a little bit of algebra, okay? What you should find out is that the initial velocity in the vertical, the initial velocity, the hypotenuse of that triangle is 85.5 meters per second. All right, so another projectile question. So we have a cannonball being launched at the top of a mountain. So we have a horizontal and vertical. The acceleration here is 0. The acceleration here is negative 9.81. We know that the initial velocity in the vertical is 0. We also know the initial velocity in the horizontal would be 20 meters per second. We know that it's being fired from a height of, and the distance in the vertical direction is the 100 meters. Okay, so if we look at this, it says how many seconds does the ball take to reach the ground? Okay, and you're always going to use the direction that you have more information in. All right, so in this direction I have 3 pieces. I can always find a 4th, and then this direction I only have 2. Okay, so use your reference tables once again and take a look at what has D, V, I, A, and T, and that's going to be the 4th one. And in the vertical, the initial velocity is 0. So I'm looking for a time, and I'm going to do the algebra here. I have D equals 1/2 AT squared. So I'm going to multiply both sides by 2, and that gets me there. I'm going to divide by A, and then I'm going to square root. So I get an expression that T is equal to 2 times the distance divided by the acceleration. And if I plug in some numbers, this is 2 times 100 divided by 9.81. If you throw that into your calculator, I got 4.5 seconds. All right, finally some circular motion. It says, which arrow best shows the direction of the centripetal acceleration of the object at the instant shown? So the object's here. And so what we know is that, yes, the velocity is tangential, so the velocity is tangential, and the word centripetal stands for inward. So the inward would be to the left, so that would be answer choice A. All right, so on this case, we're looking for the centripetal force. So centripetal force in your reference tables is m times AC, and you're told AC is v squared over r. So you can either do this in 2 steps, okay, or you could do it all in 1 step. If you put these 2 together, you get the F sub c equaling mv squared over r. And so if I plug in some numbers, I have a mass of 5, I have a speed of 2 meters per second, I square that, divided by 0.7. And so I got 28.6 newtons for my centripetal force. All right, and finally, the last one. A child is riding on a merry-go-round. As the speed of the merry-go-round doubles, the magnitude of the centripetal force acting on the child. So, all right, we're going to take a look at using the same equation, that centripetal force equals mv squared over r. So what I'm doing is I am doubling the velocity. Okay, so that's putting a 2 in front of the v. And since v is squared, I have to change this side of the equation not just by 2, but 2 squared, which of course is 4. Okay, so that concludes the midterm review video solutions for this upcoming midterm exam. If you obviously have any questions, come and see one of us, and good luck with your studying. All right, thanks for listening. Have a good night. Bye-bye.